The following content is supported by victoris.org.
Okay, so in the previous 3 lessons, we learned about first variables, then we learned about conditionals, and then we learned about functions, right? Functions are routines that you tell the computer to do. They allow you to run a certain chunk of code, right, without needing to write out the entire chunk of code. You can define inside a function, then you just call the function multiple times, right? So today, on the theme of repeatability, we'll talk about loops. Okay, so let's do a. Actually, this is the same Kahoot we did just now. Never mind. So why am I showing a picture of this giant industrial robot? So what's one reason we learn coding? We want to automate certain processes, right? You hear about automation, stealing people's jobs away, all these menial repetitive tasks that can be replaced by machines. So when you let's say you're tasked to program this robot, what will you roughly tell it to do? So let me just open up Replit. So this of course is not actually programming a giant robot, but it's kind of, I'm trying to simulate I'm trying to put a point across. So so if let's say we had the giant robot, right? I was tasked to code this giant robot to do certain tasks. So maybe I'll say print robot go left, telling the robot some instructions to go left. In reality, this would probably be a lot more code, but let's say robot go left, okay? And then I'll tell robot go right. And then let's say robot go down. Something like that, okay? And then, of course, the robot is part of an assembly line, so it needs to repeat this task many times, right? So in this case, I repeated it 3 times. I'll put some spacing to make it clearer. You can see that it does robot go left, robot go down, robot go right. Three times, okay? Then let's say, so one issue is, what if I suddenly want to do this many more times, right? I want to do it, let's say 100 more times. So what's one way? It'll be to copy paste this code many more times. But what's a more efficient way to do it? Okay, it'll be and the problem is right now, let's say the factory owner, he wanted me to take in the user's input. So he says number of times equals to input, int input, how many times. So I first asked the user how many times I want to do it. How many times? And then now I want to do this that many times. So you ask the user how many times. Let's say I say 3. In this case, it'd be correct, right? But if I want to do it, let's say 5, then you want to do it 5, then now I need to copy paste this 2 more times, but I can't even do that because how many times I need to execute these 3 lines of code depends on the user's input. I need to like change the code when it's already running. I cannot do that, right? So that's where for loops come into the rescue. Okay, so now instead of writing copy pasting, I'm going to write a for loop. So I write for to start the for loop, and I'm going to write for I in range and the number of times I want the code to repeat. So how many times? In this case, let's say I'm going to repeat it 3 times. Okay, I'm just going to comment this out first. Let's say I want to repeat 3 times. Okay, colon. So colon once again tells you that it starts a code block. Whatever has the indentation is part of the code block. So in this case, I want these 3 lines to be part of the code block. I put indentation in front of them. Okay, so now if I run this, you see that it says robot go left, right, down, left, right, down, left, right, down 3 times. Now I've just written it 1 time, but by writing this for I in range 3, it has executed lines 4, 5, 6 3 times. So the code was like lines 1, line 2, line 3. Line 3 tells me to run line 4, 5, 6 3 times. So you go 4, 5, 6, 4, 5, 6, 4, 5, 6. Make sense? And now what if I want to do it 5 times? I can just change one number over here to 5. I just change one place and tada, now I don't need to copy paste any more code. Okay, and so this right now you may be wondering, you may be skeptical. It still seems like I can copy paste, right, if I was more determined. But when you start to ask the user for how many times they want to do it, that's where I can replace this 5 with number of times. And now, whatever the user input as a number of times, if I input 1, it's just going to do it 1 time. If I input 3, it's going to do it 3 times. And if I do it 5, it's going to do it 5 times.
What does the I in the for I in?
Excellent question. Glad that you asked that. So, but you understand this concept first, right? When I for I in range a number, it's going to run whatever is inside the for loop this number of times. Okay, so what is the I for? So let's say, okay, I just, okay, I'm just gonna say do something because it's a bit too much to output. So do something. So I write 5. It says do something 5 times. Now, this is a variable. This I is a variable to count the number of times that the things has happened already. So what if let's say I do print something. I is a variable. So what can I do to see the value of a variable? What can I probe? What can I do to probe the value of the variable? I can do print I, right? So let's observe. So by printing I was curious what the variable I was. We see do something 0, then do something value of I changed to 1, value of I changed to 2, value of I changed to 3. So what can you infer from this example? So remember the lines that are executed, right? The progression of the code was line 1, line 2, line 3, line 4, line 5, line 4, 5, 4, 5, 4, 5, 4, 5. So when it runs line 4, it just says print do something. When it runs line 5, it was 0. Then in the next iteration, I changed in value to become 1. In the next iteration, I changed the value to become 2. And so on. So what does I do? What is the value of I? What value does I hold?
The number of times that line has already been repeated.
Yeah, exactly. So I close. They say that line has already been repeated. Instead of that, it's actually the number of times that the for loop has executed, starting from 0. Okay, so or rather you can think of I as a variable to keep track of the number of times the for loop has completed. Okay. So in the first iteration, I has the value of 0 because it hasn't completed yet. So sometimes there's a saying that you might hear saying programmers start counting from 0 is because of this. And it makes more sense when we talk about lists because in lists, right, you actually start counting from 0. Yeah. So okay. So you may be wondering, one question right now is, hey, didn't I say in the first lesson that the variable stores value and the variable only changes value when you say like I equals something else. Like over here, I didn't write I equals to anything at all. But why is the value of I changing? That's maybe a question that may arise. And the answer is that when you write for I in range, right, number of times, internally Python would say, okay, you have tasked me to, you give me the variable I, and the Python itself, this for loop itself would automatically update the value of I. So I didn't need to manually update the value of I over here. Yeah, so internally, I changed in value even though I didn't write I equals to anything explicitly outside. So that also means that you can read the value of I inside the for loop, but it's risky, very risky, to write like, let's say I equals to 4 over here. Because if I change something like that, right, there's gonna be funny results, and it's gonna be a bit unpredictable because the value of I is being changed by the for loop, and it's being changed by myself. So it generally is bad practice. Whenever you have like for I in range, you just read the value of I only, can use it to do other math and stuff, but you do not want to change the value of I by yourself. Yeah, leave changing of I to the Python. Okay, so if I write, let's say 9, can you guess what's the output going to be?
9. 9 times of that.
9 times of that, and so it's gonna say do something, and then what's the next line?
0.
Yeah, do something.
1.
Yeah, correct. So do something 0, do something 1, all the way to do something 8. Why is it 8 and not 9? Because it goes 0, 1, 2. So in total there's 9 times of it occurring. Each start from 0, so 0 to 8. It's gonna take a while to get used to this 0 counting, but it's okay. Yeah. Okay, Ken. So let me just take a look at Okay, so yeah, we just went through all that. Okay, so anatomy of a for loop. Okay, so sorry, this one doesn't have that much Kahoot. Yeah. So okay, so besides, so let's say I comment out do something. So right now I'm just gonna print 0 to 8, right? But what if I print I times I? Can you guess what output is gonna be? Oops, sorry, I times I. So I had a yes.
1, 4,
Yeah. So 0, 1, 4,
9.
9 and so on. And you see that just by typing just these 3 lines of code alone, I have generated square numbers to as big as a value I want. Right? Powerful, right? And what so this is where your so I can even generate nicer things like let's say right now this is all the square numbers. I can have a formatted string and then I say I times I equals to I times I.
Why you put the F in front?
Oh, F stands for formatted. Remember, we want to print the value of a variable. If I didn't have this F, then it's literally gonna say this string. So remember, when we have a formatted string, then we have curly brackets. Inside the curly brackets, the you can print the value of a variable. Yeah. So if I write this, then let's say I put 100. You see, it ran it in like 1 second, right? Just generated all the square numbers from 0 to 100 times 100. 99 times 99. Yeah, with just 3 lines of code. So that's the automation that comes in when you talk about loops. Okay. So a bit more, right? So okay, I'm just gonna for the sake of brevity, I'm going to replace this input part with just a fixed number lah. I don't keep on typing in. So I'm gonna write print before. I'm gonna print after, and inside the for loop. So if I run this, right, you see that print so the what's the order of execution over here is line 1 creates a variable called number of times equals to value of 5. Print before, we see before appear. So line 1, line 2, line 5, total of 5 times. So it's 1, 2, 5, 5, 5, 5, 5. What's that for? 5, 5, 5, 5, 5. Yeah, and then it goes to line 6. So you see line 2, 5, 5, 5, 5, 5, line 6. Okay? Yeah. So for loop will basically trap the execution in this repetitive thing until number of times runs out. Yeah. Okay. So yeah. So actually let's attempt for loops Q1 to Q4. Okay, yep, correct. So okay, if you forgot the syntax, remember it's float and then the round bracket and input. Yeah, input and round bracket, and then inside the round bracket you put a prompt. Okay, now for I in range, yeah, you need to create a variable. In this case, you call it number to store the number of times that the user has inputted. Okay. So right now, something that because does it make sense to say, because if number is a float, right? Let's say number could be potentially 2.5. Does it make sense to say do it 2.5 times? Like, doesn't really make sense, right? So this float should be changed to int. Yeah, that's right. Great. So if let's say I just want to see the mail, let's say I don't want to see the number of times it run. Yeah, then I just delete the line. So okay, can.
Let me internalize this stuff.
Sure. You can take your time to digest.
Okay, can.
Can. Okay, great. Okay. Any questions?
So far, I think okay, can.
Great. Okay, then let's go to Q2. So in this code, I want you to generate the even numbers from 2 to 12 using a for loop. So I want 2, 4, 6, 8, 10, 12.
Okay.
Okay, if you're stuck, maybe you can first consider how many lines are there from 2 to 12. Right, there's 6 lines, right?
Oh, wait.
Yeah, for I and range. So you need the round bracket and inside. Okay, 5, sure. Okay, print I. That's good start. So yeah.
Mm.
Okay, so how do we
Oh.
you can think about it. So how do we have 0, 1, 2, 3, 4. Right? How do we generate 2, 4, 6, 8, 10? You want to map 0 to 2. We're going to map 1 to 4. Is there a formula you can follow?
Probably, but I need to.
Okay, you don't need to think too hard. You can also like just try random stuff in some sense. You can just tweak the formula around until you get it to the one you decide. Usually it's completely acceptable to tweak, run, and then keep on iterating on that revision.
Your pen paper.
Okay, maybe I'll just help you out here a bit, okay?
No, I think.
Okay, you think. I can find a pen and paper. Ooh, good job, very good. Just that I want the 12 to appear also. So what can I do? Excellent. Yeah. Great, you got it. Okay, so yeah, good job. So just to share a bit of, you got it correct. This is completely good. Good implementation. Usually my thought process would be something like, okay, so usually how I'll do it systematically is if I want 2 to 12, right? So how many lines are there? I first count the number of lines to first tell me how many times I need, what number I need to put in here. The 6 lines, right? So I know if each line I print one number, I need to print a total of 6 lines. So that's how I know there's 6 instead of 5. So I write for I in range 6. And then I'm just going to print I first because I want to slowly go back and forth and see the output. So 0 to 5. Okay, so how do I print 2 from 0? And okay, so one thing I might try to do is I'll think, okay, what is 2? What's the pattern over here? Is print 2, print 4, print 6, right? And the pattern over here is 2 is equals to 2 times 1, right? 4 is equals to 2 times 2. 6 is 2 times 3, correct? So this 2 times 1, 2 times 2, 2 times 3. Now I want to generate 1, 2, and 3 from 0 to 5. I don't want 0, this annoying 0. If I just print 2 times I, it's gonna tell me 0. Okay, let me just comment this. If I just print 2 times I, it's gonna tell me this pesky annoying 0 is there, right? So what can I do to get rid of it? That's where you did the plus 2, right? So 2 plus I times 2, that works. Another way is, another train of thought is I want to generate the numbers 1 to 6 first. So I print I plus 1, and then over here I do 2 times I plus 1. Yeah, both works. Yeah. So the benefit of this thing is, let's say I want to generate all the positive square numbers, then I can do I times I plus 1 times I plus 1. Then it'll be 1 to 36. If I did the previous way, then I need to like I times I plus 2 I plus 1 kind of thing. So, and if you want something, right, you just start from you just do it I plus 1, and then whatever you want with it, you can even declare a variable inside here saying x equals to I plus 1. Then now this part is even simpler. That'll make sense, right? Yeah. So each time I'm reassigning a new value to the, and now this x is something I can play with because I just cannot change the value of I. Over here I'm reading the value of I and storing in x. The for loop doesn't care about x. The for loop only changes the value of I. So over here I can do whatever I want with x. Yeah. Okay, so now we're gonna move to an exercise that is going to be interesting. Okay, so question 3. Yeah, good start. So ask the user for a positive integer and delete one of the quotes, not the bracket. Yeah. So yeah, that's right. The input doesn't have the colon, remember? Only the conditionals, the functions, and the for loops have the colon at the back.
Don't have.
Yeah, don't have. Okay, if you need a hint, you can take a look at the need a hint section. Yeah, you can look at line 3, right? Instruction 3.
S equals
Or you can just do s equals s plus I. In this case, since you have number plus 1 over here. Would that make sense?
no.
No? Okay. Okay, let's take a look, okay? So, if I put over here, right? Okay, I'm going to create a variable outside called s equals to 0. I set it the initial value of 0. The s stands for sum. It's going to keep track of the current sum so far. Inside here, I'm going to write s equals to s plus I.
But why would the sum be plus I?
Okay, so at the end of it, let's just print s. Okay, right now your number is not defined, so I'm just gonna fill it in for you. Number equals to int. Okay, let's try it out. Let's observe first, see whether it works first. I put 5, 15. I put 100, 50, 50. It works, but what's happening inside the for loop? Okay, let's break it down. Okay, so okay, let's say I start from scratch. So if let's say s equals to 0, how does sum 1 plus 2 plus 3 plus 4 plus 5? Right, one way is to write s equals to, s is supposed to represent the sum, so 1 and 1 plus 2 plus 3 plus 4 plus 5. Okay, and then end of it, let's print s. This will give me the sum from 1 to 5, but it's not good, it's not extendable, because if let's say the user inputted 10, I need to plus 6 plus 7 all the way on, right? And there's no way to tell Python like plus dot dot dot. I cannot tell Python like recognize the pattern until n, because Python doesn't understand that. So what I can do is what is this? What's one way I can rewrite this in a more Python friendly way? I'm gonna say s equals s plus 1, and I'm gonna say s equals s plus 2, and then s equals s plus 3. Make sense? So the first one, I'm incrementing s by 1. Second, line 4, I'm incrementing s by 2. Line 5, I'm incrementing s by 3. And this goes on until s equals s plus 5. Right? Make sense? So far?
Oh.
Yeah?
Okay, yeah.
Okay, but this is still not fully extensible. I cannot tell Python dot 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 s equals. I cannot tell fill in the gap, fill in the blanks, and
Yeah, S
100. I cannot tell him to fill the blanks. What's this dot 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 part? So you see there's a repeating structure now. S equals s plus something that's increasing. And remember we just saw over here, we can generate 0, 1, 2, 3, 4. It's increasing numbers, right? So I can put this entire thing in a for loop for I in range 100. And now inside here I put s equals s plus I. Okay, but this is still because
I keeps increasing, right?
yeah, because I keeps increasing. So in the first iteration, okay, so maybe it'll make sense, right? If okay, I'm just gonna put 6 over here. Okay, so I'm just gonna put over here I'm gonna print the value of s. Okay, the partial value of s. So remember this will run 6 times, right? This lines 4 and 5 will run 6 times because there's 6 over here. So in the first iteration, it prints s 0. In the second iteration, s is 1. So you see, it added 1, then it added 2, then it added 3, then it added 4, then it added 5.
Why?
Because if I print the value of okay, I'm just gonna add some debugging statements to help. Adding I to s. Remember I, right, took on the value 0, 1, 2 in each iteration. In the first iteration, it says adding I, what is the value of I? Is 0. Adding 0 to s, because I write s equals. This line increments s by I. And in the next iteration, it says adding 1 to s. Make sense? Yeah, so that's the idea. So yeah, does it make sense? 明白吗? No.
The adding 1 to S, but I understand if you write it out, but why? But then why when you delete it?
Okay, if I delete it, so in the first iteration, it's effectively saying s equals to s plus 0, correct? In the first iteration, it's s equals s plus 0 because I has the value of 0. Okay, so remember, okay, let's step back a bit. For loop, line 4 tells me to run lines 5 and 6 because they had the indentation. Runs line 5 and 6, total of 6 times, right? And each time it runs, it run line 5, line 6, line 5, line 6, line 5, line 6. So line 5 updates the value of s by some amount I. Okay, and line 6 prints the value of s to the screen. Then, what's the thing that we see in line 6? You see 0, 1, 2, 1, 0, 1, 3, 6. It's all the partial sums. Okay, so in the first iteration, s equals s plus 0 because I is the value 0. So what's the value of s initially? So like inside the for loop, right, s is constantly being repetitively being increased, but each time is being incremented by the value of I increases in value. Okay, so if we step back a bit, remember the s equals s plus 1, s equals s plus 2, s equals s plus 3, and so on, right? What I just did, this is repeating code. Repeating code with the structure of s equals s plus something. Now we just figured out, right, from, okay, if I comment this out, if I just print I, if I just print I, you see just, I'm only printing I, it sees 0, 1, 2, 3, 4, 5. If I print I plus 1, it says 1, 2, 3, 4, 5, 6. Okay, so now I say s equals to s plus this value of I plus 1. So this is saying, okay, if I print the entire thing out, right? Okay, let me just print the entire thing out so that it's
Oh, I kind of get it.
kind of get it. Okay, so okay, now I'm just, for every command I'm gonna accompany it with, for every command that I write, right, I'm gonna accompany it with a print statement. So s equals to s plus, I'm gonna print the value of s plus the value of I. So this is kind of saying, okay, let's do this first. Remember just now I printed I plus 1. Closing bracket. Okay, if I change this to 100, it does it all the way to 100. S equals to S plus. Now I'm printing the statement S equals to S plus. The value of I plus 1 to the screen. You see the value of I plus 1 keeps on increasing, right? Because I is the counter. Alright? So if I so this is the print statement of this line. Right? This is just for cosmetic purposes. Whereas this is the line that actually does the computation. This line, I'm just saying I'm printing out, each time I'm running this, I'm also printing out the accompanying thing to the screen. So s equals to s plus 1, what would that do in English? It increments the value of s by 1. Whatever value s was, if s was, let's say, 5, then after this line, s will be 6, right? If s was, let's say, 7, after this line, s will be 8. Then this line, what does it do?
So say s was 5 at first, then
Okay, yeah.
s becomes 6.
Mm-hmm. Then next line,
Then
s
it becomes 8.
yes,
Then it becomes
11. But what did s start from? S started from 0. The value of s started from 0. So what was the first one? It was 1, right? After this line is 1. After this line is 1 plus 2. After this line is 1 plus 2 plus 3. After this line is 1 plus 2 plus 3 plus 4. After this line is 1 plus 2 plus 3 plus 4 plus 5. Right? After this line is 1. After this line is 3. After this line is 6. After this line is 10. but 10 is actually 1 plus 2 plus 3 plus 4. So after the ith line, it was 1 plus 2 plus 3 plus 4 plus I, all the way to I.
I kind of get it.
You kind of get it?
I get it.
Okay, great.
Then let me look at the code again.
Sure.
So this will run.
Mm-hmm.
Say if the number is 10, then this thing will run 10 times.
Actually, it will run total of 11 times because you added plus 1.
Oh.
But yeah, that's the idea. It will run on the order of number times.
And each time it runs, the I increases by 1.
Yeah.
Oh.
Makes sense?
Okay, yeah, I
Yeah.
get it.
So
yeah,
each
yeah.
time it runs, I would go from the first iteration I0, second iteration I1, so on. I will be 0, 1, 2, 3, 4, and so on. And now, for each one of them, I'm saying S equals to S plus I, means S equals S plus 0, S equals S plus 1, S equals S plus 2. And what does that do? That increments S by 0, that increments S by 1, that increments S by 2, and so on. All due to incrementing S by number. And what does that do? That effectively calculates the sum from 0, 1, 2, 3, 4 all the way to number. Right? Because each time I'm incrementing it by that amount. Yeah. So in the end, the value will be stored in S. The sum that we want. You see that Gauss, he was a really clever guy who, I'm not sure you heard of the trick before that if you calculate this sum, what do you do to it?
The start and the end.
Yeah, correct, start and end. Then you flip over, right? Then you realize that the sum is the same. The arithmetic progression. It's called arithmetic progression in JC. Yeah, so actually Gauss, if he had access to a computer, it'll be much easier. Yeah, they don't need to do the manual calculations. Can? Yeah. Yeah, can. So this is what I mean by logical building blocks. So what logical building blocks was involved now is variables, number, and S, right? Input, and then you have there's no conditionals here, but there's a loop, and inside the loop there's a relatively complicated variables concept, which is incrementing a variable by some amount instead of just saying like x equals to something. Now this is a concept where it starts to piece together and you can do really powerful things with it. Okay, so if not, let's jump to an easier exercise where we just fix the errors. Okay, yeah, so we can go to Q4. Yeah, so the expected output is like this, right? But if you try to press run, then it's gonna be a bit problematic. Yeah, that's good. Yeah, that's good. So that's for the for loops exercises. There's gonna be another loop later that's called while loop. But let me just show you a bit of what's the possibilities that we can start to do. Okay, so so one thing you can start to do with for loops is when I have a for loop. Okay, when I have a for loop and I print I, whatever code that's inside the for loop, it just has the indentation, right? That means that I can put conditionals inside the for loop. I can put function calls inside the for loop. I can put for loops inside the for loops. I can have a for. Now I want to, instead of for I in range, I'm gonna have another variable because I is already used to keep track of the outer for loop. So I just have a for j in range. Usually we go ijk lah, but you can name it anything you want. You can call it puppy or whatever. Okay, so for j in range 10. Now, okay, what if I do print? I'm gonna do a formatted string. I and j. So this is okay if you don't fully understand this. I just show you what's the possibility. So you see 0, 1, 0, 0 for the first iteration, 0, 1, 0, 2, 0, 3. So what this is trying to say is that line 1 told Python to run lines 2 and 3 10 times, right? And line 2 told line 3 to run 10 times, right? So line 3 actually runs a total of 10 times 10, which is 100 times. Yeah. So it's like so the execution, okay, if I change it to a smaller number, let's say I change it to 3, okay? So it will be line 1, line 2, line 3, 3, 3, 2, 3, 3, 3, 2, 3, 3, 3, and so on. So you see, total of 9 lines over here. Okay, and I and j, you see that for the first 3 times that the for loop run, for the first three times that lines tree run, I has the value of 0, but it's j changing. And then the next 3 times, I has the value of 1, and it's j taking 0, 1, and 2. Right, so you see j happens 0, 1, 2, j goes 0, 1, 2, j goes 0, 1, 2, and I has 0, 0, 0, 1, 1, 1, 2, 2, 2.
Oh.
It starts to get a bit mind-bending, right? Okay, so what's the point of this? So, times table, right?
Oh.
I've just generated a times table. Okay, this 3 is lame, right? So let's do 10. Variable here, variable here. Right, I've just generated a times table all the way to 9 times 9. I can change this to 100 times 100. Python has no sweat doing it. Right, I've just generated a huge times table. What do you 99 times 99? Okay, but that's not very... so that's one... You can see that with just 4 lines, you just done quite a lot of computation. But some stuff are useless. Like 0 times 0 is useless. 1 times... 0 times anything is 0. So we don't want to have 0. So what can we do? We can put a conditional inside. If I greater than 0, then we do this. Then now all our I is no longer there. All our 0 times something is no longer there. But 1 times 0 is still there. So we can actually, if we move this inside, and if I greater than 0 and j greater than 0, then do it. So now we don't have the annoying 0 times 0s. We just generated all the useful times tables, right? Okay, so, never mind. Let's just remove this part too. Okay, so this is a times table, again. Yeah, but there's something we note over here. You see 2 times 3 is 6, right? It's the same as 3 times 2, which is 6 also. We don't want to repeat ourselves. The timetable is actually a triangle, right? So what I can actually do is I can change this n to I plus 1. Then now it will only generate up to... You see that now we have 2 times 3. We have 2 times 3. Oh no, we don't have 2 times 3. We have 2 times 2, and then we have 3 times 2. There's no 2 times 3 anywhere, because j only went up to as much as I plus 1. I only went up to I. Yeah. So you can nest these for loops to... I've just generated some times table with just these lines of code. Yeah. So this is called nested for loops. There's more stuff we can... so another thing is, how do we generate pi using Python, using for loops? Formula for pi is the circumference divided by diameter. But in the first year of CS, we... Let me find a good sequence to generate. In the first year of CS in school, we did this as an exercise. Okay, so let's just pick this one lah. So you see that 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 plus 1 over 9 and so on is forever is pi over 4. It converges to that. If you go on forever, it converges to this number. Okay? So I can actually generate the value of pi using this sequence. So how can I do that? It's okay if it's a bit confusing. I'll just show you it's possible. So let's say generate a sequence up to 100 numbers, because by then the 100 term will be quite small, so it'd be a good approximation for pi. Okay, so I want to generate 1, 3, 5, 7, 9 first. Okay, so how can I do that? I print I as starting point. Then how do I generate 1, 3, 5? It's all the odd numbers, so the formula will be 2 times I plus 1. So now I see 1, 3, 5, so on. Okay, but it's not exactly 1, 3, 5, right? I want to actually print the quotient of 1 over that thing. Right? So now I have... It's 1 over 1, 1 over 3, 1 over 5, and so on. Okay? Then now, so this value... Okay, let's store it in X. Okay, let's store it in X. And then now, actually, if it's I need to alternate between minus and plus. So what can I do? I can have a conditional if I mod 2 equals to 0. If it's even, if the ith term is even, then I want to plus this. Otherwise, I want to minus it. Okay. So I'm just printing out to the screen at the moment. I'm not doing any computation, but you see plus 1 over 1 minus 1 over 3. That gives me an indication that I'm on the right track, right? Because I can segment the logic out already. Okay, so that I just need to compute the actual sum. So what would that be? So I'll have a variable. Just now we had s, right, outside. So I have s equals to s plus x over here. S equals to minus x over here. And then the end of it. So this is the end of it will be pi over 4. So I can print 4 times s, and that should give me pi. Okay, scroll all the way down. 3.13. Not bad, not bad. 3.14. I can just increase the bounds. Okay, I don't want to print that much to the screen, so I'm just going to comment these lines out. Now we see that as we increase the value of n, it gets closer and closer to the approximation of pi. If I increase to, let's try 1 million, okay? Let's see if this becomes 5. 3.14, 159. Okay, great. If you increase even more, you get a closer approximation of pi even. So with just for loops and conditionals and variables, we can manage to calculate the value of pi, approximate the value of pi to higher and higher precisions. I want higher, I just add more zeros here, but it's going to take longer to run. And next time, yeah. So that's the power of coding in general. You can, if you know the logic building blocks, you can piece together in any way you want to compute anything you want. Not anything. There's a lot of things. Yeah. It's okay if this is a bit too much, but I just